All right, so this video clip is about Dalton's law of partial pressure. And Dalton's law really gets used if you have a mixture of gases. So we're going to go back and just kind of review one of the ideas of the kinetic molecular theory first. And that one is the one that states that because a gas is mostly empty space, it doesn't matter what kind of gas you have, it only matters how many molecules of that gas you have, or how many moles. We're going to extend that idea a little bit further to say that it also doesn't matter if all those gas molecules are the same or if they're different. I could have 5 moles of oxygen gas, or I could have 2.5 moles of hydrogen gas and 2.5 moles of helium gas. Under the same conditions, because you have a total of 5 moles, they will exert the same amount of pressure. So that's the idea behind Dalton's law. So we are going to use some of our knowledge from the gas laws that we've learned and get you to realize that the total, T stands for total, the total number of moles in a mixture is simply equal to the sum. Remember that sigma from math means sum. The total number of moles of each kind of gas. So if I take gas X plus gas Y plus gas Z and so on, I get the total number of moles. Likewise, because it doesn't matter what kind of gas it is, the total pressure is also going to be equal to the sum of the partial pressures. So a partial pressure is simply, so this stands for partial pressure. The partial pressure is simply equal to the pressure that that gas would exert if it were all by itself. So by combining several gases, we've got these two ideas. So now we're going to take that one step further and apply it to the gas law that involves pressure and temperature. So we're going to modify the P over N. We're going to modify this one to make it a little bit different. What we're going to do is we're going to say that the total pressure of the system is equal to, or divided by the total moles of the system, is going to be equal to the partial pressure of whatever gas you're talking about, divided by the moles of that gas. So if you have a mixture of gases, you can get the individual partial pressures by using this kind of an equation if you know that information. Obviously, you have to know 3 of the variables in order to solve for a 4th. This idea comes into play, it's actually this idea comes into play in the lab that you're going to be doing. So this is the last piece of information you need in order to be able to successfully work the lab up. So in our lab, we're going to say that the barometric pressure is represented of the total pressure, the air pressure. Inside the eudiometer, that total pressure is going to be equal to a mixture of gases. Most of the gas, or most of the pressure I should say, is coming from the hydrogen gas that we generated from the reaction. But because we collected it over water, the partial pressure is, or the total pressure is also responsible as a result of a little bit of water as well. So between those two, you have the total pressure inside the eudiometer. And so that pretty much takes care of all the ideas from Dalton's law. It's pretty easy. So you can see we've got this idea where the total is equal to the sum of the parts. And then we've got the proportion where the total is proportional to any part of the ratio. So you're going to have to use both of these in the problem set. And then you're going to have to use this guy in the lab. All right, so go ahead and try those problem sets.